In this video, I want to talk about monosaccharides, which are just simple sugars. I want to talk about the difference in how to draw the D form versus the L form, and the alpha anomer versus the beta anomer. And I'm going to do this for, I'm actually just going to show you the Hayworth projections for all these different sugars, but I'm only going to do the example for one particular sugar, and then I'll post a link for you guys that kind of gives you a description of all these different monosaccharides. Okay, but first thing I want to do, I'm going to draw the first example I want to do is glucose, and specifically I want to do beta D glucose. So glucose is a six-membered ring with the O in the top right, and because it's D, I have a CH2OH going up. Now, the way I remember how to draw glucose is when I think of glucose, I think of milk duds, because milk duds are sweet and they're full of sugar, and glucose is a sugar, and that's fun and easy. Okay, so in order to kind of understand why I even wrote milk dud here, is that we have to number these carbons, keep an eye on them. So there's 6, 5, that's carbon number 4, 3, 2, and 1. So it's those are the 6 carbons there. Okay. Now, this in order is carbons 2, 3, 4, and this dud here, DUD, stands for down, up, down. So the OH on the second carbon goes down, the OH on the third carbon goes up, and the OH on the fourth carbon goes down. Okay, so that's how I remember that. Now, I want to split the page in half and kind of show you how that's different from alpha D glucose in just a second. But what about the OH that goes on the first carbon? Because it's beta, the OH is going to go up and be on the same side as the CH2OH. Okay, so the way I kind of keep that in mind is I think of beta equals batter up. That's just what helps me remember. That's specifically for the D form, right? But the technical definition of beta is that the OH on the anomeric carbon, which is this carbon, right? That OH is going to be cis, or on the same side, to the CH2OH, right? They're both on the same side. They're both up. Okay. So how does this differ from alpha D glucose? Well, alpha D glucose differs only at the anomeric carbon, right? So most of it is going to be, actually let me draw that a little bit bigger. Alpha D glucose looks like this. So it's still a D sugar, so the CH2OH is going to be up like that. And this is still going to be down, up, down, right, for carbons 2, 3, and 4. The only difference is that instead of the OH group going up, the OH group is going to come down, so that it's alpha. So I know that alpha has to be trans, right? The OH group has to be trans to the CH2OH, and they are. This one's going up and this one's coming down. So this OH group is trans to the CH2OH. Okay. Now, how do you draw the L forms of these? Well, the way I remember it is that if I just draw the D form, the L form is the same thing, except everything that was up is now going to be down, and everything that was down is now going to be up. So if I draw beta L glucose, right, that's going to be the enantiomer of this. So still the 6-membered ring, just like this, with the O up, with the O right here. Right now, instead of the CH2 going up, it's going to come down below the plane. This was down, up, down. Those are all going to be reversed. So it's going to be up, down, up, right? And this OH was up, so now it's going to go down. Notice that this is still beta, right? So we would expect to see the OH group on the anomeric carbon. We want that anomeric carbon OH to still be on the same side as the CH2OH, and it is. Okay, so I'm going to just circle these anomeric carbons in purple. Okay, so now I'm going to do alpha L glucose, and that's going to look like alpha D glucose, except everything's flipped upside down. CH2OH comes down. There's going to be up, down, up for these OHs. And here the OH was down, so now it's going to go up, and it's still trans to the CH2OH because it's alpha. Okay. So now, the kind of way to remember, I'm going to do a few more sugars, right? Doing glucose, galactose, fructose, ribose, and deoxyribose, because those are the most important ones to biochemistry. I'm not going to manipulate them all in the same way. Instead, I'm going to, like I said, I'm going to link you to a sort of PDF of all these different sugars drawn the correct way. So, I'm henceforth, for the rest of these sugars, I'm only going to draw the beta D form, and then I would expect that you would manipulate it according to the sort of the way you should remember it. So, so beta D galactose is also a 6 carbon sugar, and it's on the 6-membered ring as well. So beta D galactose, it's D, so the CH2 is OH is going to go up, but now it's not going to be a milk dud. For this one, it's DUU. Okay, so again, carbons 2, 3, and 4. So it's going to go down, up, up. Those are where the OHs go. Now it's beta, so it's going to go up and be on the same side as the CH2OH. Okay, so this is beta D galactose. All right. Now the next one I want to do, henceforth, like I mentioned, I'm only going to draw the beta D forms. Okay, because that's sort of the way I remember it. I just remember the beta D forms, or the D form really, and then I just remember how to manipulate it if I want something else, right? So here, the next one is going to be fructose. Okay, so I'm going to draw beta D fructose. Now fructose, it's a little bit weird. It's a 6-carbon molecule. It's a 6-carbon sugar. Actually, let me go through and note really quickly here that this glucose is a 6-carbon sugar. Galactose is a 6-carbon sugar as well. Fructose is also a 6-carbon sugar. But fructose is a little bit different in that it's a 6-carbon sugar, but it's in a 5-membered ring. Okay, so this 5-membered ring looks like this for fructose, where the O is up top here. Okay, so it's still a D sugar, so the CH2OH here, the 6th carbon, is going to be pointing up. Okay, so now let's number these carbons like we did with glucose, because now we have a 5-membered ring, so that might be a little bit different. So 6, 5, 4, 3, 2, or missing the last one. So I'll actually show you what happens in just a second. But for fructose, I think of the acronym, I think of fructose is just UD, right? FUD. So that's just for carbons 3 and 4, right? So this one's going to go, so carbon number 3 is going to be pointing up, carbon number 4 is going to be pointing down. Okay, now it's beta D glucose, which means that the OH has to be on the same side as the CH2OH. So the OH is going to go up this way, so that's going to be beta. But now where's that first carbon? Well, it's going to be right down here as a CH2OH. Okay, so that's where carbon number 1 is. Okay, in case that was kind of confusing. So fructose is a little bit weird there. Okay, but the same idea applies, is that this here's the anomeric carbon, and that for in order to draw this, you would just manipulate it in very much the same way that we did up here with glucose. Okay, so that's glucose, galactose, fructose. 2 more that we want to do. First one, let's do ribose. So let's do the beta D form of ribose. Okay, so ribose is also in a 5-membered ring, right? And ribose is actually a 5-carbon sugar. Okay, so it's actually a 5-carbon sugar. So it doesn't have a CH2OH hanging off this first carbon here. So D sugar, CH2OH goes up, right? Ribose, I think RDD. Ribose, DD, down, down, right? And that's for carbon numbers 3 and 4. Okay, so the carbons are numbered 6, 5, 4, 3. Oops, not 6. I just said it was a 5-carbon sugar. What am I doing? This is carbon number 5, 4, 3, 2, 1. So, excuse me here. This is actually carbon number 2, and this is carbon number 3. Okay, forgive me for that error. At least I caught it. Okay, so here at carbon number 2, we're going to have an OH going down, and this carbon number 3, an OH going down. Okay, now it's beta, so the OH is going to be on the same side as the CH2OH, so it's up, and that's it. That's ribose. Okay, ribose is important when we're talking about nucleic acids, right? RNA, ribonucleic acids. This is the sugar, the pentose sugar that they're actually concerned with, right? Pentose, 5 carbons, 6 carbons is a hexose. Okay. So the last one I want to mention is deoxyribose, which looks like this. It looks pretty much exactly like ribose. So I want to draw the beta D deoxyribose, okay, which is also a 5 carbon sugar. Okay, it looks nearly identical to ribose. The only difference is that the 2' or the second carbon, carbon number 2, instead of it's deoxy. It doesn't have an oxygen here at carbon number 2. It's just a hydrogen and another hydrogen here. Okay, so here there's no OH group. Okay, so it looks just like ribose. Except carbon 2 has no OH group, right? And that's where the deoxy comes from. You lose that hydrogen. It's just a hydrogen at the second carbon there. Okay, so we go back to these carbons: 1, 2, 3, 4, 5. Okay, so this is beta D deoxyribose. So let's not forget this OH going up here. So then that's essentially it. What I'll have now is, if you want to draw any of the other forms, you would simply manipulate them, knowing that you know all these different things here. That if you wanted to turn it from a D to an L sugar, you just take everything that was up and put it down, everything that was down, put it up, and then keep in mind that the beta has to be cis to the CH2OH, and the alpha has to be trans to the CH2OH. Like I said, I'll post a PDF along with this video so that you can see how the remainder of these drawings look. Okay, I hope that was helpful, and good luck studying this stuff.